Hello everybody, welcome to marketing analytics course. We are in week 8 session 4 actually, and we are discussing market basket analysis. Till now we have discussed about what is the requirement of market basket analysis and the basic easier version of the algorithm. Now let us talk about a priori algorithm, which is the advanced version, which can be used for larger data sets. So I was here in this presentation. I will just scroll it up, and I was basically just 1 minute. I was here in the presentation. Yes. So, I was talking about find the rule in 2 stages for this particular thing. So, find all items with a specified minimal support. So, first of all, you will not do it for everybody. I will only find out those guys which have minimal support. So, item set is just as a specific set of items, like I told, when apples and cheese occurred. What was the rule, if you remember? When apples and cheese occurs, honey also occurs. So, apple and cheese is the item set. So, the first I will choose such kind of combinations which has a minimum cutoff, minimum support. So, what is that? Let us say I will say 10 out, or at least 1%. 1% of the whole data set they should occur. Less than 1% will not even consider those combination. That is number 1. Now, use these items as to help generating the rules. So, you do not create a rule, you just break based on certain conditions. So, having done stage 1, we have considerably narrowed down the possibilities and can do reasonably fast processing on the large item sets to generate candidate rules. So, but this is what we do. So, we find out all the products and market of proportion of market baskets containing these items, and then we do something. So, for an example, terminology says that there are k item set, let us say a set of k items. So, if it is a 3 item set, that means a set of 3 items. If it is a 1 item set, then it is a set of 1 item. 2 item set means it is a set of 2 items. What is support? An item set has S percentage support, that means in the data set there are S percentage transactions which has these 2 guys together. And what is the minimum support? The a priori algorithm starts with the specification of a minimum support. So, we do not use all item sets, we only use those item sets which has a minimum number of occurrences. Let us say if my database is 20 million, as I told 20 million, and I am saying 1% should occur. That means what? That means basically 200,000 times that item set should occur. 1% is a very big number actually. We do not even say 1%, we say 0.01%. 0.01% means 1 by 10001, 10 to the power 4. So, 20 million comes to be 20 billions 0.01% is basically how much? 2000. So, 2000 times one item set should occur, then only we will go ahead and create the rule, otherwise I will not create the rule. So, that is the first job. What is a large item set? Does not mean an item set which with many items, it means one whose support is at least higher than the minimum support. That is how we use this large item set definition. So, LK is the set of all large k item sets in the database, and CK is a set of candidates. So, CK is a set of candidate large k item sets. In the algorithm we look at, it generates this set which contains all k item sets which might be large, and then eventually. So, CK is basically one particular item set in LK. LK is the superset of all large k item sets in DB. And what is large? Large is basically the item sets which has support more than the cutoff. So, that is something that we will use. These terminologies we will use to define the algorithm. Now, here you just see that which are the 3 item sets. So, if this is the product, one of the 3 item set is A, B, H, and A, B, H is occurring here, A, B and H is occurring here, and then A, B and H is occurring here, A, B and H is occurring here. So, ID number 1, 18 and 19, in these 3 cases A, B and H is happening. So, A, B and H is a 3 item set, 3 dash item set, because 3 items are there. Its support is 3 by 20, which is 15%, right? Yeah, this which is 15%. Similarly, A comma I is a 2 item set whose support is 0%, nowhere it is occurring, and etc. So, now if I take the cutoff as 10%, then this guy will be a part of my large, this guy will be a large item set. So, if the minimum support is 10%, then B is a large item set. You see that, but B, C, D, H is a small item set, because this is occurring only 5%, but B is occurring 1, 2, 3, 4, 5, 6. It is a one item set which is occurring 6 times out of 20, that means 30%. So, which is a large item set. So, minimum support is 10%. So, the a priori algorithm for finding large item sets efficiently in big databases. So, this is the algorithm that is saying. So, it find all large one item sets, that is the first job. That means, find out which items are occurring at least 10% of times, if that is your cutoff. Then for k is equal to 2, while L k minus 1 is non-empty, k plus plus. So, when L k minus 1 is non-empty, it is not blank, then increase the k, otherwise keep the k like that. So, if 2 items are not occurring 10% times, then 3 items will not occur 10% times. That is, let us say A and B together are not occurring 10% times. Then can A, B, H occur 10% times? No, right. So, if A and B, this is not occurring 10% times, that means A and B is not a part of the large data set, large item set, then A, B, H cannot be a part of the large item set. So, you will further find out item sets for only those guys whose individual items were there in the earlier version. That means, let us say when I am trying to analyze 2 item set, I will only use those products for which one item set was a part of the large category. So, to give an example, let us give an example what I am trying to say here. I am trying to say, I will just change the page size and etc. Okay, let us talk about, let us make it. Okay, so, I am trying to say that I have item 1, item 2, item 3, item 4 and item 5, and these items, this has 30%, this is 5%, this is 25%, this is 9% and this is 12%. Fair enough. Now, I am saying that I will find out 2 combinations. Now, if 2 has occurred only 5% times, then 2 comma 4, can it occur more than 5% times? No, because 2 has occurred. So, out of where 2 has occurred, one subset is where 2 and 4 will occur. So, this will be always lower than this, the percentage of this will always be lower than this. So, I will not see any combination which has this probably. So, I will probably also not see any combination which has this. I will see only the combinations of these guys. So, that is something which is important to understand, that okay, so this guy, this person and this person is something that I will consider, because the 1 and 3 happening together will be always be lower than the individual probabilities, 1 happening together. So, this is something. So, from here what are the 2 item things I will say? Then I will say that 1 3 I will check, 1 5 I will check and 3 5 I will check. Fair enough. Now, let us say 1 3 is around 20% and 1 5 is around, let us say 9% and 3 5 is around, let us say 11%. Fair enough. Now, what is the probability that 1 comma 3 5 comma happen? See, one subset of this is 1 3, another subset of this is 1 5, 1 3 occurs 20%, 1 5 occurs 9%. So, this guy has to be lower than 9%, has to be, because out of those cases where 1 5 occurs, there are some cases where 3 also occurs. So, this guy has to be lower than 9%. So, I will practically not consider this combination, because this is the combination which is not a large one, 10% was my cutoff. So, then I will, so if I do not consider this, basically I am not consider other 2 combinations will also give me this. So, I am not consider any 3 item set. So, the only 5 only item sets which are there in my these things. These are my L1s and these are my L2. L3 is 0, L3 is blank, non-empty. So, only for non-empty data sets it is saying whenever L k minus 1 is non-empty, then only you go ahead, otherwise you do not go ahead, otherwise you do not increase k. And then you do the same thing, you find out what are the how many sets are there, how many counts are there, the one that I just shown in the basic picture, they find out the count. So, they reduce the number of choice sets. So, you can run this particular algorithm in the database and you will find out that these are the 3 item sets which has 10% support. How do you generate the 4 item sets might have 10% support? So, anybody which one combination of these you will find out, and if they have 10% support, then you consider them as 4 item sets. So, one possibility is that note all of these items are involved A, B, C, E, F, G, H to R, generate all possible 4 combinations, and then you find out who of them is, but that will again take lots of times. But hold on, we can easily see that A, B, C, E could not have 10% support, because A, B, E is not one of our 3 item sets. See, A, B, E was not at all in our 3 item set. So, A, B, E cannot have 10% support. So, then A, B, C, E also cannot have 10% support, if A, B, E cannot have 10% support. So, I have to create combinations in such a way such that these guys, so all the subset of the original these combinations are there here, all the possible subsets. So, A, B, C has to be there, B, C has to be there, A, C, all possible subset of the 4 item combination should be here. Then only we can go ahead and find out that particular guy's support, otherwise we will not find out. So, the same goes for several other of these subsets. So, enforce that subsets are always arranged lexicographically and they are already on the left. Only generate k plus 1 items from k items which differ in the last item. So, that is what is the algorithm that they are giving. And this case the only 5 items will be A, E, G, R, W and N, Q, R, T, F, you can check that. So, only the last item they are changing, the first 3 items they are putting it lexicographically and changing the last item. So, this trick guarantees to capture the items that have enough support, will still generate some candidates that do not have enough support. So, we will still have to check them in the pruning step, and is particularly convenient for implementation in a standard and relational style transactional database. So, that is what happens in the background of a priori algorithm. So, there is some example given, I will not spend my time on this example, you can check out, and then we try out and find out the rules, that what kind of rules. And what can we say about the coverage of apples and milks? We can invest several potential rules. If basket contains apples and bananas, it also contains milk. So, this is something. So, support of A, B is 40%. What is the confidence of this rule? You have to find out that. So, the items has been taken from these 2 links. You can also go and read more details from these links, and in the next video we will actually do in a hands on way how to deal with this thing. So, some appendix and this thing is also there in the presentation, you can look out and try out on your own. So, thank you for being in this particular video. We have discussed the algorithm and we have discussed the usage of market basket analysis in quite a bit. In the next video, we will actually discuss how to do it in R in a hands on way. Thank you very much.